This is the ocean, the home to the most wonderful and beautiful creatures on this planet. A collaborative community of sea creatures and sea plants working together to provide for one another. But no peace stays on this earth. These ecosystems are being destroyed by us. What are we doing? How are we doing it? And what is happening to these poor corals?
With our careless use of fossil fuels, we are polluting our atmosphere with thousands of tons of CO2 by the day. Not all of it actually stays up in the atmosphere. Some of it gets absorbed by the ocean in a reaction called ocean acidification. Ocean acidification occurs when CO2 from the atmosphere is absorbed by the ocean. The CO2 then reacts with the seawater and produces carbonic acid, which then releases bicarbonate and hydrogen ions into the ocean. These reduce the pH levels and the ocean to make it more acidic, hence the name ocean acidification. Now this is very detrimental to life in the ocean, because it breaks down corals, which are home to millions of marine species. With ocean acidification reducing pH levels, corals and seashells are dissolving and degrading. Animals with exoskeletons are getting softer shells, which will decrease their survival in the wild. We decided to conduct a lab to simulate pH levels dropping when CO2 is added. In this lab we will create CO2 with bicarbonate soda and vinegar. Then from the reaction of the two, we will collect CO2, which we will then add to seawater. We'll then get a seashell and weigh it before putting it in the seawater.
It is fully submerged.
We'll then wait a week and then weigh the seashell again. This is to see if the seawater dissolves the shell, due to the decrease in the pH level. Our prediction is if we decrease pH levels with CO2, then the weight of the seashell will also decrease, because due to the pH levels dropping, the seawater will be more acidic and will dissolve the shell. Alright, we waited a week, and the results we got were, well, surprising in a way. So a thing that we did, and we messed up on this lab, we didn't end up measuring the original weight of the shell. We never found out how much the shell actually changed. But one of our group members, called DJ, so thank you DJ, he went around and collected the other weights of the other shell that other people were using. Then he averaged it and got 2.57, which is the average of the seashells we were using. So we did this lab on a Monday, and then we measured it again on a Friday. We then got 1.97. And just to let you know, this is all in grams. So from Monday till Friday, the seashell lost about 0.6 grams. Now, of course, this isn't accurate because we didn't end up measuring the original shell. After each time we added CO2 to the seawater, we measured the pH, and the CO2 was around 100 milliliters. So the original starting pH was 7. Then it dropped down to 6 in our first one. Then it stayed at 6 with the second time we added CO2. With the third time we added CO2, it went down to 5. Then we added 10 more milliliters of vinegar. We then got 5 again, not surprisingly. But then it went back up to 6 and stayed like that till our 7th. If we're still considering our starting pH was 7, then we dropped down by 2. Now this is just talking about 5 days and talking about a small lab experiment where a lot of different factors could affect the end result. But now think about this on a bigger scale. Think about this with thousands of tons of CO2 getting absorbed by the ocean and then decreasing the pH levels dramatically. In 2 weeks after we did the first lab, the seashell looked like this, completely smashed. Think about that happening to actual corals. Corals, where thousands of species of marine life live, and is dismantling and destroying habitats. Not only for marine life, but also affects coastal areas where people live. And one of them is the Coral Triangle, which is called the most diverse coral reef on the entire planet. The Coral Triangle is known as one of the most richest ecosystems on the planet. 76% of marine species are found inside the Coral Triangle. Some people also call it the Amazon of the sea, rightfully so, because it matches both richness and diversity of the Amazon rainforest. This reef also supports the livelihood and income of communities surrounding it. This reef might sound like marine heaven, but is also being affected by ocean acidification. Just like how the pH change in our seawater, the pH is changing in oceans surrounding the Coral Triangle, which then leads to some detrimental changes to the ecosystem. Let's take for example reef-building corals, which have a symbiotic relationship with photosynthetic algae called zooxanthellae. What's it called?
Zooxanthellae.
Zooxanthellae. The corals provide protection for the algae as well as compounds which it needs for photosynthesis. In return, the zooxanthellae provides the coral with carbohydrate, which it uses for food and oxygen. Quite a nice relationship. But with ocean acidification destroying corals, the algae will soon not have protection and the compounds it needs for photosynthesis. That's just one of the many examples where animals and corals work together to build a livable environment, but now are being destroyed and dismantled by ocean acidification. Now, what are people doing to help? Many organizations which work with protecting marine areas are working to create marine protected areas. Many locals of coastal areas are also helping. Now I can tell you to minimize your carbon footprint, but I won't. You can still do something, but you can't really do that much. The people that can make change are people in power, such as politicians and huge corporations. But mainly politicians, which have the power to put laws in place and minimize the amount of CO2. Now that is being done around the world, but the big polluters aren't doing anything. We will only realize what we are doing is wrong when the last coral, the last fish, and the last species die out.